this lesson is about electronegativity, and electronegativity is the tendency of an atom or a functional group to attract electrons towards itself. Electronegativity is affected by two things. The first thing is the atomic number, and the atomic number is important because it tells us the number of protons that an atom has. The second thing it's affected by is the distance the valence electrons are from the charged nucleus. And this can be more simply stated as the atomic radius. So, thinking about these two things, we're really talking about the interaction between these protons and electrons. So we know protons have a positive charge. And electrons have negative charge. So, the atomic number affects electronegativity because the more protons an atom has, the more positive charge it has. And that positive charge is better at attracting electrons because they have a negative charge. So therefore, that is one big factor in determining, how well electrons are attracted towards an atom. The kind of opposite part of this is dealing with that atomic radius, because if the valence shell of electrons are really far away from that nucleus, the positive charge doesn't affect the electrons as much. So electronegativity increases when you have a smaller atomic radius, and it also increases with higher atomic number. There's a general trend on the periodic table that the electronegativity of an atom increases as you go up and to the right. And this makes a lot of sense because atomic radius also decreases as you go up and to the right. And the number of protons increase across a row. So therefore you have the most protons possible in one row or one period on the right hand side, and you have the smallest radius in the top of the periodic table. So thinking about this, the most electronegative element that we know of, that we have good data on, is fluorine. And that's because fluorine has a very small radius, the smallest radius, and it has a good kind of proton to radius ratio. So we're going to look at an example here that kind of will let us try and determine which is more electronegative. And we're going to see if calcium or iodine is more electronegative. So over here I've drawn a periodic table, and we have calcium and iodine kind of wrote out where they are in the periodic table. And we have some data over here showing our atomic radius for calcium as 197 picometers and for iodine as 140 picometers. So let's look at those things electronegativity is affected by and determine which one of these is going to be more electronegative. So if we use the first part, we can see that the atomic number comes into play. So calcium has the atomic number of 20, as you can see in this little picture. So it has a pretty decent number of protons, but at the same point we have to look at its radius, and its radius is 197 picometers. So iodine, now if we look at it, has an atomic number of 53. and its radius is 140 picometers. So we look at what electronegativity is affected by. The first thing shows us that, well, the higher atomic number, the more protons, is iodine. So iodine kind of gets part 1. And if we look at it in terms of the radius of iodine is also smaller. So it has more protons, and they're closer to that valence electron orbital. So iodine iodine's electronegativity is much greater than calcium's electronegativity. And this is because iodine has more protons or positive charge and it also has a smaller atomic radius. So this is how you can compare two atoms to see which one's more electronegative using these two different things electronegativity is affected by.